Welcome back to the Chapter 6 Circular Motion and Newton's Applications in Part 2. I'm Sorasak Phanphak, your instructor. We did learn about how to using a circular motion and involved with the Newton's law and try to explain the phenomenon. For example, we know as the centripetal acceleration, right, is equal to v squared over r. By this, we apply with the second law of Newton so that we can find the net force is equal to mac in centripetal direction, or like in inward direction of the circular motion. So we will use this relation try to solve this problem. How about that? So with this, civil engineer decides the curve of the exit lamp while this car is cornering. So think about the previous question. We have the car with the circular motion try to cornering like this, moving this way, right? And the reason that this car can moving as a circle due to the friction of the floor, right? And with the radius of curvature, with this parameter, car can be on the curve without skating out. That is the reason. But at this time, with the lamp or with this type of the exit kind of things, you have a car on the lamp, and in this case we don't have any friction yet, so there's no friction happen here, and this is what the car moving on the lamp and also in a circular motion. So this is still in a circular motion. This one you have the friction, but this one have no friction, but you also have this lamp instead. So let's see how can we use the reasons of the normal force as the centripetal force involved into this circular motion. All right, properly. Circular motion. So how we start from this type of the calculation, I will show you here. So thinking about all of these involved in terms of parameter, what you have seen here, you have the mg of the car going downward, which is this is fg, this is the mg, the weight of the car. With this one, when you try to normalize it or break these components, you will have N, which is the normal force, right? Normal force, which is normal force is this type of mg. If you know this is theta, this is also theta, this is mg cos theta. But this is not the things, because in order to investigate the circular motion of this, we try to find the relation. And for example, this case, you would like to identify the angle. How about what this angle that can have this car to have the cornering in this circular motion? And I said this is in the case of the frictionless. There's no friction along this part, so the main influence is due to the slope or this angle. So if we think as this system and we let design the axis like this, if I want to have the upwards as a y-axis and right way or maybe left way is the x-axis, for example, if I look along the x-axis, what you have seen this nx is the direction that pointing toward the central of the circular motion. So this is supposed to be the centripetal force. So your nx is Fc, which is equal to mv square over r, which is r is the radius of the curve, which is 50 meter. This is your r. So now you look at x-axis. So look along y-axis as well. We change the color. What is happening along y-axis? You can see ny is equal to fg. So this is your ny is equal to mg. But n is the things. So how to get the nx out of the ny? So by this, if you know the relation of n is m cos theta, something like this. But I now would like to determine only term n, that kind of thing that we'll get rid of later. So with this definition, if you break the component of n close to the theta, your ny is n cos theta, and your nx is n sin theta. So that I will got nx here as the n sin theta, and ny here is n cos theta. I don't care about no matter what I'm breaking the component of mg here, but I'm care more about the n, because I know that finally n gonna get rid of each other. But the term is important are theta or radius and maybe velocity, because we got the velocity information here as well. And g, we know that we use g equal to 9.8 meter per second square here. Right, these are all important parameters. M or n, it will get it off finally. So I got equation 1 and equation 2. So if I have equation 1 divided by equation 2, I got the mv square over r and divided by mg. Maybe I'll write properly. By mg here. Right, equal to n sin theta over n cos theta. So that you can see m is m, can get rid of it, and n also can get rid of. Finally, you get the tan theta here equal to v square over rg. To find the theta, to find the angle the curve can be banked to have this car moving with this speed. So we can find the arctan, or I can write like this, maybe better. Arctan of v square over rg. So that the arctan of v square, which is 13.4 square over r, 50 meter, and g is 9.8, which is, I will find the angle around 27.6 degrees. And you can see this is how I'm not care about changing the breaking the component of fg to mg cos theta, and then that is n, because I know that finally this is gonna go away, and you have only the information of theta and v, r, and g. That's all your information that you have here. This is your v, this is your r, and theta is what question asking you about. And g is here the constant, the gravitational acceleration. Let's look at the next question. So this is on the Ferris wheel, right? You may play when you may have ride this when you were young, but how to calculate all these important information? So have a look. So if this child have a mass m, right, on the right of this wheel, and this wheel rotate like this. Thing is, if you would like to determine the force that exert by the seat, that means a kid have its own mass, right, and sat down on the seat. His mass is mg, and the force that exert by the seat is the normal force, right? But whether n equal to m or not, it depends on acceleration. Whether acceleration is upward, acceleration is downward, or it may be left or right handward. Why the reason supposed to be like that? Because the source of acceleration here not only due to the centripetal acceleration, sometimes it also have the gravitational acceleration as well. It depends on the position. It depends on the position of the first wheel, whether at top or bottom or on the sideway. This is a key. So you have to recheck whether the acceleration is upward, downward, leftward, or right handward. The first one would like to determine the force exerted by seat on the current at the bottom of the right. So this is the diagram at the bottom here. Here, this guy. He sit right here, has the mg downward, right? And also have the centripetal acceleration pointing toward the center. Express your answer in terms of weight of these children. This child, sorry. So only this guy on the bottom as the diagram 1, you will know this is the free body diagram. When you look after only this boy on the right, then you see the mg of this boy pointing downward, while the normal force that the seat act to this boy is pointing upward, and also with the acceleration. So now, if you would like to determine the force that exert on the seat in the bottom seat of this first one, free body diagram, so you can apply with the second law of Newton, with sigma F equal to ma. Since the acceleration that pointing here is the centripetal acceleration, this is equal to mac. So what is your sigma F? You can see the direction that the AC pointing upwards is n bottom minus mg. So this is n bottom minus mg equal to mac, where the AC is the v square over r, right? So now, if you would like to determine the exert force, that means you need to determine the n bottom. It's like in the elevator. Can you remember that? If you would like to weight yourself on the balance and the elevator pointing upward, so you have your mass mg, you have the normal force to send. In this case, you will gain your weight while you measuring your weight, so that your apparent weight, or in this case the exert force, is mg plus mv square over r. If you like to answer in terms of mg, so how can you do it? You can reduce the term so that you can multiply by g and divide by g, so that you get v square over rg. And finally, what you get, you're gonna get n bottom equal to mg 1 plus V square over RG. This is how you get the value of n bottom. If you sub all the parameter in, so now I would like to determine exert force is equal to mg sub v in, so the v is 3, so 3 square over r is 10 and g 9.8. That is how you get the exert force at the bottom is 1.09 mg in terms of newtons. Mg is not milligram, but mg is the mass multiplied with gravities, because it would like you to answer in terms of mg here, right? And if you would like to determine in the next step for the seat of this kid, right on the top of the Ferris wheel, so how can you find it? So let's have a look here.